In this problem, we want to verify these inequalities. When we're verifying something, we already know that it's true. We're just demonstrating that they are true. And so we have these three different problems, and I'm going to do these in three different ways to demonstrate that you can do them in any way of your choice. The first way I'm going to show with letter A is by using the idea of common denominators and equivalent fractions. And so let's take a look at 5 and 4 and make our Venn diagrams with their factors. And so 5 is 5 times 1. 4 is 2 times 2 times 1. Using the Venn diagram, we're going to have 5, 1, 2, 2. So 5 times 1 times 2 times 2 is going to give us a least common denominator of 20. In order to get the least common denominator of 20, I used the Venn diagram. And so now I'm going to multiply this denominator, 5 times 4, to get that 20. And that means I also need to multiply the numerator by 4 for the equivalent fraction of 16 over 20. Now I'm going to place the negative out front. Notice how I ignored that during the process of finding the common denominator. It's absolutely something you can do. I just kind of put it on at the end. Looking at the other side, 4 times 5 gives us the 20. 3 times 5 will give us 15. And then I'm going to bring down my negative sign. I'm also going to bring down my inequality. Since now we have the denominators of the common denominator of 20, we can ignore those and look at our numerator along with the inequality symbol. Is negative 16 less than negative 15? Absolutely. So we have verified this inequality to be true. For letter B, we have 1/10 is greater than negative 1/4. Well, this we should absolutely know at the beginning of the problem, that positives are greater than negatives. But let's say we're either not paying attention or both are the same. Either way, what we're going to do is change these two to decimals. Decimals are sometimes a little bit easier to compare than fractions. And so 1/10 is 0.10, 1/10. 1/4 is 0.25, and since this is a negative 1/4, we're going to put a negative sign there. Is 10 cents, and I always think of decimals in terms of money, is 10 cents greater than negative 25 cents? Negative 25 cents would be maybe you owe somebody money. So you either have 10 cents in your pocket or you owe somebody 25 cents. And so having 10 cents is definitely larger than owing somebody 25 cents. And so this is verified. So 19 times 3 over here, we have 27. 3 times 1 is 3, 4, 5. So that would be a negative 57. Notice I put the negative 57 on the left. So if I multiply in the upward direction toward the left, that number goes on the left-hand side of the inequality. Multiplying in the upward right direction, I'm going to put that number on the right-hand side. So 60 times -1 is -60. Is it true now that -57 is greater than -60? When we're thinking about negatives, a lot of times I like to think about money. I either owe somebody $57 or I owe somebody $60. Well, I would rather owe them $57 than $60. And so that means that that number is greater. And so that has been verified. This diagonal multiplication definitely does work, this cross product idea. However, you really have to remember that you got to multiply up. Multiply up.